Next. Suppose that you flip a coin twice. What's the probability that you get two heads? Okay. So you're telling me 2 out of 4. Now why do you say 2 out of 4? Okay. You're not flipping it 4 times, you're flipping it twice. Okay, so there are 4 possibilities, and there's 2 heads and 2 tails, so that gives you 2? Okay. So you say 4 out of 4? How'd you get 4 out of 4? Uh-huh. Okay. Okay, you're actually on the right track, yeah, Bruno? 1/4. And how do you get 1/4? Okay, so you just skipped ahead 10 minutes. So you're quite right. Right. Yes, and that's what we're.
Oh no.
Okay, so one way to think of it is how many total possibilities are there? Now, when you flip a coin twice, how many total possibilities are there? This is what we're going to work out right now. So one way to see this is using what's called a tree. So on the first flip, what can you get? Heads or tails? Let's write that down. Now, after you flip a head, what can you have? You can either get a head or a tail. And after you flip the tail, you can flip a head or a tail. So what is the first total event? Reading this tree from left to right, what's the first total event? No. What's the event? What event does that represent? The first event is head. What's the next event represented on the tree? Head, tails. What's the next event represented on the tree? And then, does everyone see it now? Okay. Now, so how many total possibilities are there? 4. How many of them have 2 heads? So the probability is 1 out of 4. Now, I'll tell you right now, this is the long way to do it. But I just wanted to make it clear that this is where 1 out of 4 comes from. Now we're going to talk about. We're going to get to a quick way to do this. First of all, what kind of situation is this? This is a compound event. So what's a compound event, and how do you know when you have a compound event? I like to say that if you can say first event and then second event, that's a compound event. So what are the compound events? What are the 2 events that make a compound event in this problem? You flip a coin and then you flip it again. Okay, that means a compound event. Notice that this is different from previous question, draw 1 card and see if it's a king or a spade. You don't get a king and then get a spade. That's not what's happening. You're only drawing 1 card. Is that distinction clear? Okay, so make sure you keep that distinction in mind as you're working on problems. Okay, so how do you find probabilities in a compound event? Well, first let's think about how did we find the total number of possibilities? Well, how many possibilities are there for the first flip? How many possibilities are there when you flip a coin 1 time? 2 possibilities. Now, on just the second flip by itself, how many possibilities are there? 2. There are 2 possibilities on the first flip, 2 possibilities on the second flip. So how many total possibilities are there? There's 4. And how do we get that? Where does the 4 come from? 2 times 2. Exactly. So when you got a compound event, you're going to get your answers by multiplying. So in exactly the same way, How do you get the probability? We're going to multiply. So what's the probability of flipping head, head? Well, what's the probability of flipping the first head? When you flip a coin, the first time, what's the probability of a head? It's 1 out of 2. First flip, 1 out of 2. On the second flip only, what's the probability of flipping a head? 1 out of 2. What do we do with those numbers? We multiply. And what does that give? 1 out of 4. And there you go. Compound event, first event and then second event, get the individual probabilities and you multiply. Okay. So for example, if you flip a coin 4 times, what's the probability you get a head, head, tail, head? What's the probability to get a head on the first flip? What's the probability that on the second flip you get head? What's the probability that on the third flip it comes up tail? And what's the probability that on the fourth flip it comes up head? And what do you have to do with those numbers? And what does that give you? And there you go. Now, the long way to do this would be to make a tree. So, which way would you rather do? Right. Okay. So, making a tree helps you write out every possibility, but you don't need that in order to do these problems. You dig? Okay. Okay. So, suppose you roll a die. What's the probability you roll a 6, then a 3, then a 2, in that order? So what's the probability that on the first roll you get a 6? Okay. 1 out of 6, 1 out of 6, 1 out of 6. If you multiply it together, that gives you 1 out of 216. Which, by the way, is approximately 0.0046, so it's quite small. I want you guys to work on these problems. Yes. Quick comment, the first 3 problems you should be able to do with a little bit of thinking. Notice the last 2 problems have a bunch of stars on them, so they require a little extra thought. Okay. So, what's the probability that 2 people are both born on a Tuesday? Sorry? How do you get this? And how do you get that? 1 over 7 times 1 over 7. After the previous problem, this should be more clear where that comes from. So 1 over 49. Good. Next, flip a coin and roll a die. What's the probability that it comes up head and 5? And how did you get that? Okay, which gives you 1 over 12. Great. Is that straight? Okay. Now, suppose the probability of a sunny day is 0.6. Over 3 days, what's the probability you have sun, no sun, sun? 0.6 times 0.4 times 0.6. And if you worked it out, that's 0.144. Now, where does that 0.4 come from? It adds up to 1. So where does the 0.4 come from? No. If the probability of sun is 0.6, how do you get the probability of no sun? 1 minus 0.6. Okay. Now, I have to throw in a follow-up question here. What's the probability that you have 0 sunny days? Again, over 3 days. What's the probability on the first day? No sun. 0.4 times. Okay, all days have no sun. 0.4 times 0.4 times 0.4. And if you work it out, you get 0.064. Now, what's the probability that you have at least one sunny day? What does at least one mean? Could have 1 day of sun. What else? Or 2 or 3. Doing it that way is gonna be hard to figure out. But there's an easy way to figure out this problem. At least one is the opposite of what? At least one is the opposite of none. So what's the answer to this question, probability of at least 1 day? 1 minus 0.064. Because at least one is the opposite of none. So you can just do 1 minus. Okay. Now, the star problems. Roll 2 dice. What's the probability that the sum is 2? Right, why? Right, because the dice have to come up what? It has to be a 1 and a 1. What's the probability of getting 1 on the first roll? 1 out of 6. Second roll, 1 out of 6. So it's 1 out of 36. So that was the little trick in that question. Next, probability you roll a die 4 times and get 4 different numbers. Partly right. Now, how many events does this question have? 4 events. So what we're going to need are 4 different numbers, or 4 different probabilities. Now, on the first roll, how many total possibilities are there? 6. Now, out of those rolls, how many can give you how many will give you at the end of the how many are acceptable so at the end of the day you have 4 different numbers? 6. They're all okay. Now on the second roll, how many total possibilities are there? No, how many total possibilities are there? 6. And how many of those are acceptable? 5 of them are acceptable. And on the third roll, 4 out of 6. And on the fourth roll, 3 out of 6. That was clever, right? Okay. So if you work this out, you get 360 out of 1296. Okay. Now finally, yes, we come back to the question. Suppose a family has 2 kids. If one kid is a boy, what is the probability that the other is a girl? So we need to approach this from a very basic yet clever sort of way. Probability is x over n. So the first thing we're going to figure out, well, first let's write down all possibilities. If a family has 2 kids, what are all possibilities? I'm going to use B for boy and G for girl. Okay, so you could have girl, girl, what else? Boy, boy, what else? Boy, girl, and girl, boy. Okay, so again, 4 possibilities like we know. If one kid is a boy, what does that immediately tell you? That the GG is out. It says if one kid is a boy. So what is not possible? Okay. So now, what is n? N is 3. Now, if one kid is a boy, what's the probability that the other is a girl? how many of these possibilities satisfy? 2. So the probability is 2/3. Of the 3 families, how many of them have the other kid is a girl? So the moral of this story is that probability can be very tricky, even counterintuitive. Okay? Thanks.